And we are live. What is going on, guys? It's me, Andrew, here, and welcome to episode number 4 of Andy Explains. Yes, and today we're going to be talking about what is a central processing unit, or a CPU. And what a CPU is that it interprets and carries out basic instructions that operate a computer. Okay, so inside the CPU there are two units. Okay, there's a control unit and the arithmetic logic unit, known as the ALU. And the control unit directs and coordinates operations in the computer, and the ALU performs arithmetic comparisons and logical operations. So yeah, the CPU, or the central processing unit, is also called the processor. Alright, so yeah, we can go to the next thing. And so pretty much with the processor, it follows a cycle known as the machine cycle, and there are 4 stages in the machine cycle. And the first stage is the fetch, and that is pretty much obtaining the program instruction or data item from memory, which is your random access memory, which I spoke about in the last episode of Andy Explains. So the next step is to decode, and that pretty much in that stage, the CPU is pretty much translating instruction into commands, and that is handled by the control unit. And then step 3 is to execute or carry out the command, and that is carried out by your arithmetic logic unit. And step 4 is to store the results into memory, so it's back onto your memory. So if you were to type in 4700 on your keyboard, your CPU will fetch that. It will first go into RAM, then afterwards it will be fetched by your CPU, decoded, then executed, and then it will be stored onto your memory, and there you can see it on your screen. So that is it for the machine cycle. For the next thing is pipelining, and pipelining is pretty much okay, if you ever worked at a, let's say, on a project, or like let's say you work at a fast food restaurant, and you have like a chain. One person puts on the bun, the other person puts on the patty or the burger, and then the next person puts on a ham, or well, the lettuce or whatever. That's pretty much what pipelining is, and I'll just explain it. So the processor begins fetching second instruction before completing the machine cycle for the first instruction. So it results in much faster processing. So like I said with the McDonald's example, if you work at McDonald's and you're just the only one that's making the sandwich, it'll be much slower than if you had a bunch of people lined up and each person does different things, and like someone will start like loading up the bun before the first sandwich is finished. So yeah. And then the next thing I want to talk about is that has to do with the processors. That with the processor contain registers, and registers are pretty much high-speed storage areas that hold data and instruction. Okay, so it pretty much stores instruction while it's being decoded. It stores results of calculations. It also stores data while the ALU, arithmetic logic unit, computes it, and it stores location from where instructions was fetched. So yeah, it does pretty much 4 things that I just mentioned. Alright, so your processor also contains a system clock. And when you are to go out to buy a new CPU or a new processor, usually it would say, well, 2.3 gigahertz, 3.2 gigahertz, and that gigahertz is the hertz, which is measured in clock speed. So I'll explain that right now. So pretty much the clock speed controls the timing of all computer operations, generates regular electronic pulses or ticks that set operating pace of components of system unit. And your system unit is your computer and everything that is inside of it. So each tick is a clock cycle. Alright, the pace of the system is the clock speed. Most clock speeds are measured in gigahertz or GHz range. 1 gigahertz is equal to 1 billion ticks of system clock per second. So let me rephrase that. When you see 1 gigahertz, that is equal to 1 billion ticks of system clock per second. Okay, so the processor speed can also be measured in millions of instructions per second, or MIP MPS, millions of instructions per second. Yeah, but no one really uses that. People usually measure it in gigahertz, megahertz. Another thing is that if you're gonna go buy a new CPU right now, you are thinking about getting a dual core, multi-core, single core. Well, no one's really gonna get a single core, but it's either dual core, and pretty much what a core is that a dual core processor. I'll explain that right now. It's pretty much a single chip that contains two separate processors. So it's like, think of it as like a car, like an engine or a car engine. How would I think of it? Okay, think of it as an engine with two engines inside. So it's a single chip that contains two separate processors. So it's like a single engine with two different engines inside. So it's not really a single engine. Well, it is. It is a single. Okay, you get the point. So I'll just use the definition that I know. It's a dual core processor is a single chip that contains two separate processors. Okay. Another thing is that with multi-core processors, which is pretty much above 2 and up, even I think we have like 8 cores now. Yeah, from AMD. The multi-core processors is a chip with 2 or more separate processors. So it's a single chip with 2 or more separate processors. Each processor on a dual or multi-core chip generally runs at a slower clock speed, but increase overall performance. So yeah, sometimes you will notice that if you were to, well, this is just for me, well, what I just stated, sometimes if you were to go into your like CPU Z or whatever, I'm not sure if this applies, but at times when I'm running my my CPU at the stock clock speeds, it usually says 800 MHz each core when it's an idle, but automatically bumps up. So yeah, that's just a regular side note, which you don't really have to you don't have to take into consideration. Okay, so another thing with processors is that you pretty much have to keep them cool, and if they run too hot, they will pretty much overheat and they can be damaged. Okay, so to cool these, you can use a heatsink, and a heatsink is a component with fins that cools the processor. These pretty much coolers, they contain the heat pipes, and it's a smaller. So yeah, a heatsink is a component with fins that cools the processor, and a heat pipe is a smaller device for notebook computers. So instead of like putting a heatsink on like a tab or notebook or a laptop, they put heat pipes instead. And liquid cooling, pretty much like that's the new big thing right now, is that it uses a continuous flow of fluids to transfer heat away from the CPU. Okay, so parallel processing. Alright, parallel processing uses multiple processors simultaneously to execute a program faster. Alright, so it requires special software to divide the problem and bring the results together. So this is pretty much the illustration. It's the control processor, or pretty much the CPU, the control processor, the main thing. Then you have processor 1, processor 2, processor 3, processor 4. Usually it's pretty much starts from 0, 1, 2, 3, 4. Because if you were to look in your BIOS, you'll say CPU 0, CPU 1, CPU 3, 2, CPU 3. I don't know, for some reason computers start counting at 0 instead of 1. And pretty much combines the results in the end. So you have one task, each CPU handles different aspects of it, and then it will bring it back down together, and that's much faster than a single core or serial. Yeah, serial and parallel. It's actually much faster than serial, which is pretty much one direct line. Alright, what else do we gotta look at here? And I think that is pretty much all we need to know about CPUs. Oh, right, and cache, which has to do with memory, but CPUs do contain cache. And what cache is that it helps the computer processes storage. Okay, let me just rephrase that. Excuse me. Cache helps speed computer processes by storing frequently used instructions and data. Alright, so Also, it's also known as memory cache, and you have three levels of cache. You have L1 cache, which is built into the processor. You have L2 cache, which is slower but has a larger capacity, and you also have L2 advanced, um, which transfers cache is faster but is built directly into the processor. So actually, you know what? You actually have four. You have level 1 cache, which is built into the processor. Level 2 cache, which is slower but has a larger capacity. You have level 2 advanced, which transfer cache. Level 2 advanced transfer cache is faster, but it is built directly into the processor chip. And you have level 3 cache, which is separate from the processor chip, and it's usually on the motherboard. Level 3 is only on computers that use level 2 advanced transfer cache. So pretty much cache is just, it's a place on the chip or on the motherboard where it's pretty much stores frequently used files and instructions and data, so that it's easier for your computer to access instead of having to look on your hard drive for it again. But that has to do with memory. I just pretty much mentioned that because if you were to go buy a CPU right now, you see level 1 cache or L1 cache or L2 cache, and maybe you might wonder what that is. And apart from that, I think we are done here. I didn't make a webcam video in this episode because, well, it's much easier just to pretty much talk about it. I don't have to do any extra work. So yeah, guys, if you enjoyed this video, be sure to give it a thumbs up, comment, and subscribe for more videos. So yeah, see you guys in the next episode. Peace.